Hello, this is Robert from Microchip Technology. Today I am covering the OPAMP Peripheral in the new PIC 18Q41 and AVR DB product families. Both the AVR DB and the PIC 18Q41 share the same basic operational amplifier with minor differences in a few of the implemented features. In most cases, the analog performance of both devices should be identical. The biggest difference between the two devices is the number of op-amps on board. AVR DB has up to 3 op-amps which can be interconnected together. This grouping of op-amps is also referred to as an analog signal conditioning peripheral. The PIC 18Q41 has a single op-amp on board as a part of the operational amplifier module, or OPA. At the heart of this peripheral is a general-purpose operational amplifier with a gain bandwidth product of 5 MHz. The high gain bandwidth product available enables designers to use the op-amp module as a programmable gain amplifier while still retaining sufficient bandwidth for most applications. For flexibility in development, the inputs to the operational amplifier are multiplexed internally. This multiplexing allows for a wide array of configurations including unity gain, non-inverting amplifier, and complex multi-op-amp configurations. The multiplexer's inputs include the selected I/O location, the internal resistor ladder, reference levels, and select analog peripheral outputs. Additionally, devices with multiple op-amps allow them to be internally connected to form complex implementations, such as a cascade of operational amplifiers or as an instrumentation amplifier, which is useful for analog signal conditioning. The unity gain switch allows the peripheral to be in unity gain even in cases where the internal feedback multiplexer is turned off. AVR DB implements this feature as a short circuit from the output to the inverting input with the negative channel multiplexer still active. This implementation can be used to discharge an integration capacitor. The PIC 18Q41 operates identically, except that the negative channel multiplexer is disabled. This reduces gain error caused by the parasitic resistance in the switch, however, it prevents the switch from discharging the integration capacitor. To reduce the bill of materials, or BOM, in applications that use the OPAMP peripheral, an internal resistor ladder is provided. The internal resistor ladder is designed to be utilized as a part of the internal feedback network of the operational amplifier. There are 8 steps available on the ladder with predefined ratios at commonly used gains. The ladder can be disconnected in applications where it is unneeded or where external components are in use. The top of the internal resistor ladder is multiplexed for design flexibility. This multiplexer has 3 valid connections: VDD, the output of the operational amplifier, or no connection. Selecting the VDD connection turns the internal resistor ladder into a resistor divider network. This network can be buffered by the operational amplifier to become a static DC output proportional to the ratio of the resistors. On AVR DB, this can be used to generate the DC level required for the multi-voltage I/O peripheral, which enables the device to interface with either higher or lower voltage digital logic without the need for a level shifter. Choosing the operational amplifier's output implements the internal resistor ladder as a part of the feedback network. When using the internal resistor ladder as feedback, this option must be chosen. Finally, there is a no connection option, which disconnects the top of the ladder. This mode should be selected when using external parts, which may be influenced by the internal resistance of the ladder, causing gain errors. The PIC 18Q41 has an additional feature that allows for 4 possible pin assignments for each of the analog inputs to the operational amplifier. Developers can use this feature to simplify PCB layouts or to switch between multiple different analog inputs. One key feature of the operational amplifier is the input offset voltage calibration register. The input offset voltage is calibrated in the factory to meet the specifications in the device datasheet. On a power on reset, the factory default value is restored. While there are a kaleidoscopic number of possible configurations of the OPAMP peripheral, there are 4 basic circuits: unity gain, non-inverting amplifier, inverting amplifier, and external connections. Unity gain is a high input impedance voltage buffer with a gain of 1. This configuration is ideal for full-scale signals that do not require any gain and only need to be buffered. The highlighted red lines in the diagram indicate the circuit used to implement this configuration with an external signal. Non-inverting amplifiers are high input impedance circuits that produce an output signal that is always greater than the input. This configuration can be built with either the internal resistor ladder, as shown, or with external components. When using the internal resistor ladder, this configuration is an implicit programmable gain amplifier. The inverting amplifier can also have variable gain. However, the op-amp modules are single supply, so the inverting amplifier configuration has been modified to level shift the output by biasing the non-inverting input. In the diagram, the bias is supplied by the internal VDD/2 level. The internal resistor ladder functions as the feedback network. The external connections configuration of the OPAMP peripheral is completely dependent on the components that have been connected to the associated I/O. Any arbitrary configuration of the operational amplifier is possible in this state, so long as the circuit does not violate the absolute maximum rating specified in the device datasheet. The op-amps on the PIC 18Q41 and AVR DB are powerful tools that can greatly assist in developing mixed signal applications. To configure the op-amps in the microcontroller, MPLAB Code Configurator or MPLAB Start are easy-to-use tools which can generate the APIs to configure the op-amps and other peripherals on the device. Curiosity Nano development kits for the AVR DB and PIC18Q41 are pre-programmed in the factory with software that allows for an out-of-the-box evaluation of the op-amps. MPLAB MINDI, an analog circuit simulator, can simulate the performance of the op-amps before a design is built or prototyped. This free tool is available at the link in the video description. The next video in this series will cover MINDI in more detail and show the MINDI simulation against the real circuit. Thank you for watching. Please like and subscribe for more content.